Hello, and thank you for your interest and being here and hearing me. Today, I would like to talk with you about the beneficiation of a low-grade manganese ore with the focus on high-intensity magnetic separator. My name is Rasoul Rezaei, and I'm area sales manager by STEINERT GmbH from Germany. And yeah, today I want to talk with you about this topic. Let's start the presentation. First, I will give you an overview about the challenges. Which challenges do we have in this industry? The second capital will be the case study. We will go through the case study and I will explain you what we did already in our test center here in Germany. And the last capital would be the conclusion. And I will give you a comparison between some different processing method and then after that, I've finished the presentation. Good. The challenges. The first one is our ore. Sometimes we have very rich ore and sometimes we have very poor ore. And if you have very rich ore, we have some other challenges. If you have poor ores, we have challenges with grade, recoveries, processings, and so on. Therefore, the ore is very challenging topic. The second challenge is the cost regarding the capex and the opex of the processing plant. And the third one is the processing method. The processing method, which method is much more suitable for this mineral, this type of mineral. It should be wet processing or dry processing. And the final challenges is the environment and how environment friendly is my process. And these four pillars, they are our challenges and we will discuss about during the presentation. Let's define some goal. What is the goal of this work? What is the goal of this test work? The first one is we want to think about the capex. The second one is we will discuss about the OPEX, the operational cost. And at the end, we want to know how environmental friendly is the processing method and is the technology. Okay, we are beginning with the case study. What we did is we took a low-grade manganese ore. We classified with screens in 3 grain sizes, 1 to 3 millimeter, 3 to 5 millimeter, 5 to 9 millimeter. And after that, we use a high-intensity magnetic separator. In the first magnetic separation stage, we produce the first concentrate of the manganese. In the second magnetic separation step, we produce the second concentrate. And at the end, we have the tail material. That is our methodology. And this is a picture from the material. You can see the white and the black and the gray particles. The particle size were 1 to 9 millimeter. Manganese grade in average was 9.8%. And the host rock is carbonate. You can see this white and, as I said, these gray particles. They are carbonate host rock, and even the gray particles, most of them, they had a white color. And because of the black color of the manganese, the color is changed to the gray. Yeah, regarding the technology, you can see that's the STEINERT's high intensity magnetic separator, STEINERT HGS, high gradient magnetic separator too. It is a machine with a rare earth magnet as a, it's very famous as a roll separator made from the rare earth magnets. The intensity of the magnetic field on the surface of the equipment is roughly 20,000 joules. That's a dry machine. There is no need for water, and it made from permanent magnets. And that's a 2 trommel, 1 trommel, 1 roll is magnetic roll, and the second roll is just normal. And then you have a conveyor belt, and then you can feed the material inside, and then at the end you have a magnetic fraction and a non-magnetic fraction. Okay, we took this methodology, we classified the ore, and then we used this 2-stage magnetic separation with high intensity. The first fraction was 1 to 3 millimeter. what we reach in the purity is 24.63%. In the recovery, we could recover 70.64% out of total manganese, and the mass balance on the product as a manganese concentrate with this purity and recovery was 25.28%. And the capacity of the machine was 5 ton per hour per meter. It means per meter we can manufacture the machine in smaller size, in half a meter, and even a little bit bigger in 1.5 meter. Yeah, the results for the second fraction for 3 to 5 millimeter, the purity was a little bit higher, 27.03%. The recovery very good, higher than the recovery in the fraction 1 to 3 millimeter, 84.41, and the mass balance was even higher than the final fraction, 27.47%. And the capacity even higher than 5 ton what we had with 1 to 3 millimeter. And right now we have 8 ton per meter and per hour. And the final fraction is 5 to 9 millimeter. The purity is a little bit lower, 23.5. The recovery is lower too, roughly 62%. And the mass balance is roughly in the range that we had with the other fractions, 25.8. But in this time, because of the coarser fraction or coarser size of the material, we have higher capacity. Okay, if we want to make a comparison between these three processing steps with three grain sizes, I want to show you a grade ratio. It means a ratio between the output grade as a concentrate grade and to the input grade, and then a recovery. In the final fraction 1 to 3 millimeter, we could increase the grade of the input in the concentrate to 271% with a recovery of 70.64. In the medium fraction, medium size 3 to 5 millimeter, the increasing of the grade was even higher, 308%, and the recovery is higher, 84.41%. And for the quarter fraction, you have 241% as the increasing in the grade, and the recovery is 62.61. You can see very clear here that for this application, for this type of ore, where we have a prolozite as an oxide of manganese, the grain size between 3 to 5 millimeter is the best one to have very good results in the grade and very good recoveries. It has something to do with the dips of the magnetic field of the equipment, and it has something to do with the other minerals, such iron minerals or other minerals inside of the ore. Okay, we are right now in the conclusion. In the beginning, we already talked about challenges, and then we defined some goals. And right now we want to see, okay, we did this case study, and what is the outcomes? What is the conclusion regarding these challenges and this defined goal? The first one, if you remember, it was the capex. Okay, for this processing method, screening and magnetic separation with high gradient magnetic separator, you do need a very low investment. The capex is very low. You don't need to have a big plants. You don't need to build, I don't know, very, very expensive facilities, washing facilities or other preparation facilities. Therefore, the total picture for the investment will be very, very low. The second goal was the OPEX. What is the OPEX? The cost for 24 hours working for a one machine 1 meter wide with 3 to 5 millimeter is roughly 1.4 euro in a day. With this machine and in this grain size, you will be able to process roughly 190 ton, and the cost will be 1.4 euro. That's mainly the cost for power consumption. The maintenance cost is not so high. Therefore, the machine is very robust and made for mining industry. Therefore, your operational cost will be very low. And the final point is the environment. Yeah, that's very, very important for us, because today it is very important factor, because lots of processing plants, they work with chemicals, and with waters, and you should treat everything. Then for this processing method, there is no need for chemical or using water. Therefore, it is very environment friendly processing method. And if I want to give you a summary at the end of the presentation, if you compare processing of low-grade manganese ore with dense media separation or jigging, where you use chemicals, where you use water, you should have a little bit yeah, you should think about the capex, which certainly much more than investment amount in the high intensity magnetic separation, and even the operation cost and then environmental effects will be much more higher. Therefore, yeah, in Germany we did the test, and I think we are on a good way to develop a good concept to process such ores in low capex and low opex. Yeah, that was the presentation. Yeah, I'm very happy that I could present this case study for you and introduce this old processing method with new aspects and new design for new challenges. And if you have some questions if you need some further and detailed information, please don't hesitate to contact me. You can send an email to me or call me on my phone number. You have my data right now here. And thank you, and hope to see you again. And yeah, have a nice day. Bye bye.